So for this problem, we have three different parameterizations of the same Cartesian graph, but we're going to have three different parametric equations and corresponding parametric graphs. So let's try to analyze them. Let's take graph A. We can see that x is equal to t and y is equal to 1 over t squared. So first, let's try to sketch our Cartesian graph. If you're going to plug in x instead of t, you will see that we're going to have y is equal to 1 over x squared. So that is going to be our Cartesian graph, or in other words, our skeleton for our parametric graph. Let's try to sketch it. So for that, what do we need to do? Let's first try to analyze what are possible restrictions for t, and you can see that t is equal, doesn't equal to 0. So actually my restrictions for t is that t is going to be from negative infinity to 0, union from 0 to positive infinity. So let's plug in some points in order to sketch our graph. I'm going to plug in t is equal to 1, 2, and 1/2, and then I'm going to get corresponding points. 1, 1 for t is equal to 1, 2 and 1 over 4 for t is equal to 2, and 1/2 and 4 for t is equal to 1/2. And you can see we're going to have something similar to hyperbola. But if you're going to change the sign from positive to negative, I'm going to just reflect all my points along y-axis. So I'm going to have that hyperbola on the left-hand side the same. So that's why that's going to be our graph. In order to sketch our first graph, you can see that t is equal to -2 and t is equal to -1 and t is equal to 1/2 will give us that we go from negative infinity to positive infinity, or we're going to cover left branch of our hyperbola in quotes. And if we're going to choose positive t, then we're going to cover the right branch of our hyperbola. So that orange line with the direction that I just wrote is going to be the parametric graph of parameterization A. Our second parameterization is a little bit tricky. So first, we can see that our x is going to be equal to cosine t, and y is going to be equal to secant squared t, or in other words, 1 over cosine squared t. So first, observe that our t is now just to take our t from 0 to 2 pi, since cosine function is periodic. And then bounds for our x is going to be between -1 and 1, and bounds for our y actually going to be, there is mistake, not like from 0 to 1, but y is going to be bounded between 0 and positive infinity. And then what we're going to do, we just need to take some points of t and see what is going to be kind of our initial point, what is our ending point, and how our graph is going to go when t changes between 0 and 2 pi. So when t is equal to 0, I'm going to get 0.11. And if t is going to approach pi over 2, then cosine of t is going to approach 0. But since I'm dividing by cosine square of t for y, then y is going to approach positive infinity. So that's why I'm going to cover the right branch of my function. And when t is going to approach the pi, you can check that you're going to cover the left branch of our function when we're going down. And in that case, the point -1 and 1 is going to correspond for t is equal to pi. But right now, if we're going to consider t between pi and 2 pi, what is going to happen is we're going to do the same thing, but we're just going to start at point -1 and 1, and we're going to end up at point 1 and 1. Or in other words, we're going to cover the path which is given by the green function. And finally, let's do parameterization C, where x is equal to e to the t and y is equal to 1 over e to the 2t. So first observe when t changes from negative infinitive to positive infinitive, then our exponent is going to be always positive, or in other words, x is strictly bigger than 0. So that's why we're going to cover only right branch of our function. And when t approaches negative infinity, then ux is going to approach 0. So in other words, when t is equal to 0, we're going to start at point 1, and then we kind of coming from the top, and so we're gonna go along y-axis and reach point 1, and then when t going to go to positive infinity, we're going to approach x-axis, and that is going to be our graph C. And right now we can see we have the same Cartesian graph, but different parameterizations A, B, and C, which give us different parametric graphs. Okay guys, thank you for watching. I hope you enjoyed this video. Let me know if you have any questions. If you're not subscribed to my channel, please subscribe, and have a nice day. Bye.